Nice job.
Hey everybody,
Steve.
Welcome to another edition of Minerals Live. We have Dr. James Hagadorn with us again today.
Howdy everyone.
Dr. James, nice to have you here with us.
Yeah, thanks for having me.
This is exciting. We haven't had you in a little while, and you always give such exciting presentations. This time, we're talking about something that everybody can relate to. Speleothems.
Speleothems. That's the most unpronounceable word ever, right?
You know, I spent a lot of time in the cave networks of Texas, in and around New Braunfels, and the south of Austin, between San Antonio, Texas, and Austin. They have some beautiful caves there. Yeah. And I spent many enjoyable weekends walking through the caves there.
Nice.
So that's fun.
Nice. Yeah, so that's what we're talking about today, are cave deposits. I mean, speleothem is just a crazy geological word that comes from the Greek words for cave and for deposit. And, you know, geologists use that term to kind of encompass a lot of the different minerals that get precipitated or grown in caves. And some of those you may be familiar with, like stalactites or stalagmites. But there are also a lot of really amazing minerals that people collect or study that are found in those same deposits. So.
Very true. Now, in speleothems, would you also include the wonderfully formed calcite crystals that occur there, or that is?
No, absolutely,
okay,
absolutely. In fact, I just spent the last 2 weeks in the Grand Canyon. So welcome back, everyone. And I had the great pleasure of going down. If you ever can go to the Grand Canyon, there are these deposits of travertine. They're incredible. These burbling springs that come out of the hillsides, and it's basically groundwater that's wicking through or seeping through a limestone or a dolostone rock formation, and then it oozes down the edges of the canyon and into the Colorado River, and you have these beautiful aqua and light blue colored and sometimes even kind of orangish brown colored springs all along these side canyons in the Grand Canyon, and they're precipitating mostly calcite, but a little bit of aragonite and some other weird minerals. And those deposits they're all around us, and they actually are almost like nature's cement. You know, there are places we were down in the canyon that had kind of like fossilized, what's called a debris flow, or not quite like an avalanche deposit, but where rocks have cascaded downhill to form an alluvial fan, and they've actually been petrified in place by this travertine. And so normally you go up to a kind of debris flow or something, and you could just stick your hand in it and pick up some sand. But I mean, these things you could whack on them with a sledgehammer because these springs, the same stuff that forms speleothems underground, are actually coming out on the surface and hardening these, what should be loose sediments into rock.
Well, one of the cool things about these deposits is that they're so approachable by the public. Most of the areas that we find the great mineral crystal specimens from are from active mines. You know, they're mining for ores of silver and gold and lead and zinc, and the general public doesn't have the opportunity to see where mineral crystals grow in place. But these speleothem deposits are often fairly shallow. At some cave systems that you can tour, you'll wind up going down an elevator or a set of stairs to go a few 100 feet under the ground, 50 feet to a few 100 feet under the ground, but they're relatively approachable. You can go around the country, whether it's Carlsbad Caverns or Natural Bridge Caverns or wherever you are, or Cave of the Winds here in Colorado, wherever. You can actually go in them as a citizen to see these beautiful stalactites, stalagmites, crystals of calcite, beautiful crystal groups of calcite, and they're there where you can see them where they have occurred. The formation process is different than some of the hydrothermal systems and others, but you still get to see in place where these things have crystallized in wonderful shapes and sizes or formed like a stalactite or stalagmite. So it's geology that's very approachable.
It's geology in action.
Yeah, it is.
There are even some caves right here in Colorado. Like, you can go to Cave of the Winds down south here, about an hour and a half south in Colorado Springs, or you can go up to the mountains. I'm going to point to the mountains over there, up near Glenwood Springs, which was actually first known for its caverns, actually, which have these speleothems in them. That's about 2 hours west of Denver, and there are caves that you can go in there that, you know, I took my 2-year-old in there. You could go in on a wheelchair. There are other ones where you have to, you know, go in and like slide through in the mud where your little head headlamp, but a lot of these, as you say,
Yeah.
are very accessible, and you can see minerals forming.
Yeah.
Like
Today.
minerals live in action.
That's right.
And it's just
Yeah.
happening in front of your naked eyes. It's so cool, you know.
Yeah, it really is. It's fascinating and in many cases just awe-inspiring that these natural formations can occur all on their own, and if we're careful when we go into these cave systems not to touch them, they'll continue to form and be a treasure for future generations to appreciate.
Yeah. So maybe, Steve, let's talk today a little bit about how speleothems form. Maybe we'll talk a little bit about the different kinds,
Sure.
and we'll take you viewers out there on a kind of virtual tour of those.
That's exciting.
Before we do that, we needed to acknowledge one other key player out there, and that's Amy Hoover. And so Amy is up in Steamboat today. I don't know if she's rocking it out in the mountains or on the computer or maybe with her kids, but Amy, thank you so much for helping us learn about speleothems and sharing your knowledge and love for Colorado geology with us and our readers. And Steve and viewers out there, I don't know if you guys know this, but Amy is retiring, and I'm putting that
goodness.
in air quotes
Yeah.
because, you know, those of us that look at rocks,
Yeah.
we never really retire.
That's right.
So she's taking a pause right now in helping us with these presentations to learn about Colorado geology, to focus on a couple of other important things like two little cute kiddos. But we know she's going to be back someday. Maybe you'll see her on TV. Maybe you'll see her at the Denver Museum. Who knows? Maybe we'll read about her in the paper one day doing something really cool with the geology of Steamboat.
Awesome.
But I just want to give a
Amy.
shout out to Amy, and thank you for all your help. You know, we've had a lot of fun working with you to learn about Colorado minerals and geology.
Yeah, she's been a big part of your presentations, that's for sure.
Absolutely. So just want to shout out. Can we start off with a famous piece right here? This one that says speleothems.
I think we
Yeah,
can.
right. Now this is a secret specimen, and I would like to challenge any viewers out there who are alive to identify where this specimen is right now. And you have to be specific. And are we going to give them what, like a couple of ounces of gold? No, we're going to give them like a 12-foot long speleothem of
I think we
Rhodochrosite.
should.
If they identify
Yeah,
it.
why not?
Yeah, from Richard's personal collection. No, seriously, we'd love to hear from you if you have
That's from China.
a guess as to where this specimen is. This specimen, just to give you a clue, is called the root beer float slab.
Isn't that something?
And it's a cross section of polished calcite that probably was from the Cave of the Winds. We're not entirely sure. It was collected probably on the order of a century ago and slabbed and polished. And just because of its color, it kind of looks like the bubbles that you would see on top of a root beer float with the vanilla ice cream coming out. And it's just a spectacular specimen, and it shows multiple generations of this piece. By the way, is about 4.5 feet by 3 feet in size.
Wow.
So it's not little. I would have brought it here today, but you know, it might be bolted to something right
wall
now.
on the entrance.
But was that the clue? No. Yeah. This is okay, we'll let this secret out. This specimen's currently on display at the front of Coors Mineral and Gem Hall at the museum, and
It's
we call
a
it
beautiful specimen.
we call it the root beer float slab, and more kids and visitors have come and touched it and licked it and checked it out with their hand lens than you'd imagine. So
Now, is there a way, you know, it's how this imitates nature, the biologic side. You know, you see these concentric rings of growth on inside here. Are you able to determine in any way the length of time, like a tree ring, how long this took to occur or grow?
Great question, Steve. In fact, we are. Maybe not on that particular specimen because it's on display and we don't want to drill little holes in it. But in fact, there's a whole science of speleologists who, just like people study tree rings, where each year as the tree grows in the spring, it grows a new layer. And so layer by layer, the tree records an annual signal like a tape recorder. Okay, anyone under the age of 25, a tape recorder is a device that was used to, just kidding. But it's kind of like a ruler. It measures what happens each year. Deep sea deposits or lake deposits where you have an annual deposition of silt or of organic matter are another type of climate record. Ice cores are another annual or varve-like record where each year when the ice builds up, it layer by layer forms a deposit that we can go back and count the layers, date them using radioactive minerals in them, and figure out how, for example, atmosphere changed. Well, speleothems are the same. In fact, there have been some really cool studies that people have gone and figured out, for example, that the southwestern parts of North America, by looking at the characteristics of the minerals and the should I say this, just trace elements that they can contain, as well as the isotopic composition. The isotopes are just different masses of oxygen trapped in the mineral structure of each layer. They've been able to figure out how wet or how dry it was here in the past, going back something like 40 or 50,000 years.
Isn't that great?
And
That's
so
fantastic.
you can take a tree ring record from that time and figure out, well, we think it was wetter then or drier then, and then you can take a cave deposit and do the same thing, and if they both agree and tell you the same answer, then we're more confident in saying, actually, it's getting warmer, or actually, it's getting wetter. And, and that's important because when, for example, archaeologists or anthropologists want to think about, well, why did that civilization disappear or move, 10,000 years ago? Was it because of disease? Was it because of drought? And maybe there wasn't as much food?
So you can tell that from the speleothem as well as the tree ring data.
Right, and so those are powerful tools to help us figure out how the planet has changed in the past.
Oh, cool.
And like, how did that impact people and culture? And so they're really not only important to geologists, but also to anthropologists, archaeologists, climate scientists, and the like. So
wonderful.
Yeah. But please don't go drill into our museum to sample them. We'll show you one in a minute of how that's done. How does that sound?
Sure.
Let's take a look at this kind of cartoon here for a moment. So this is kind of like a slice through the earth, and this is a simplified diagram of the gray area here, the dark gray with the kind of cracks in it. You can imagine that's a rock formation that was formed on the ancient sea bottom. Maybe it was an ancient reef that's tens of millions of years old. If you go down to Florida today, actually much of submerged Florida and Georgia and Alabama and Mississippi, and even parts of Texas and Colorado and elsewhere, I mean, there are lots of these limestone rocks beneath our feet every day. People notice that the Ozarks, great area. And so as rainwater falls into the ground and percolates down, rainwater has a little bit of carbon dioxide mixed in with it, and that carbon dioxide makes it into a weak acid called carbonic acid. And it's not too acidic. Its pH is about 6.5, so 7 is basically neutral, so it's a little bit acidic. And as that water percolates through the ground, it dissolves and works its way into cracks and fissures, and sometimes it actually will dissolve big cavities, and those cavities you've probably heard of called sinkholes. Every now and then it seems like you hear a report from Florida and somebody's car got swallowed up by one of these sinkholes where it just collapses. We have those too here in Colorado, and hopefully you get some notification before your bedroom falls into it. But that process is the same process that forms caves and kind of subterranean sewer system or water systems and aquifers that dissolve their way through the rock. And so most of these speleothems that we see are forming in underground caverns that were basically dissolved away limestone or dolostone rock. Dolostone is just rock dominated by dolomite. And in these you get, once the water table lowers so that those caves are open, you get dripping of material from the ceiling, piling up of that material on the floor. You get all sorts of strange structures, and boy, let's take a look at some of these. They're certainly fun to look at.
They sure are.
Whoa.
And what cave is this from?
This, I actually don't know off the top of my head. But it's from Wikipedia, so it must be reliable, right? This is just an illustration of some of the types of crazy mineralizations that occur in caves, and there are forms like stalactites, which occur on the top, so it has a T. That's how I remember it. It's on the top of the cave. These things are dripping down. There are straws that will form, and that's actually like as the drop kind of oozes down and hangs there. If you've ever had a drippy faucet, and if you've lived in some place where there's a lot of minerals in the water, those drippy faucets will oftentimes get like a little bathtub ring around them of kind of whitish, almost looks like dust. And if you wipe it off, that's the same stuff basically that's forming a stalactite. And only the thing is it's like having a drippy faucet for 1,000 years, or 10,000 years, or even millions of years. And so those, as each droplet kind of evaporates or falls, it leaves behind that residue, and it grows bit by bit. And so a straw is like a mineralized tube that's going down from the top of the cave.
And so it's hollow in the center.
It's hollow, you know, and the stalactites are more like a cone hanging from the roof. Stalagmites are more like a cone building up from the bottom.
And in those, generally, the water has evaporated as it's dropped. It's evaporated and deposited on the outside rather than down the straw.
Yeah, or it may not have evaporated. It may just actually have kind of oozed over the surface and left behind a microscopic veneer of typically calcite, but sometimes aragonite. There are also, we should mention, there are vapor caves. In fact, Colorado has the only natural vapor cave in North America. It's used to be called Fairy Cave, but it's part of Glenwood Caverns. And we'll show you a map of where that is and a picture of it in just a second. But it's an actual man-made vapor cave where it's kind of like going into a steamy bathhouse, if you will. And so these things can precipitate both from drips, but also from vapor, and in some cases actually from fluid. So like think about like a slow-moving underground stream, and that, depending on the water type and chemistry and velocity and temperature and pressure and so on, you can form different shapes of these minerals. And should just come out and say I'm not a speleothem expert, but boy, when I go in a cave, I'm amazed by the shapes. I mean, they have little dishes in there that come out of the wall. They look like a mushroom on the edge of a tree. And you think, is there an elf that was sitting on that?
And they'll have these fried egg deposits where, there's all sorts of speleothems that are really fascinating. Different shapes, different sizes. Just really incredible. In China, they harvest these things. Here in the U.S., we protect the caves and do a great job of preserving them. In China, boy, they sell 10-foot, 20-foot tall speleothems for decoration in homes and
we used to do that too, actually, but it was that happened a lot before we knew how fast these things regenerated. I was down at Cave of the Winds. Let's just look at a locality map here, just for fun. So let's look at a map of Colorado with all the different. Colorado has hundreds of cave deposits, and so we're up here, kind of below the U in Boulder. We're just south of Boulder. We're right now at the Collector's Edge here in Denver. But some of the most well-known cave deposits, and ones that viewers out there, if you wanted to come visit, Cave of the Winds has tours all day long. I mean, as I said, I mean, my kids are 4, 6, and 8, but I took them there when they were 2. And my grandmother went to Cave of the Winds back in the day, so it's a really famous place. But there are other ones. Glenwood Caverns is just west of Denver, about 2 hours up in the mountains, and it's a spectacular area. There's a few other cave deposits here, but I was down at Cave of the Winds a couple years ago and talking to a guy that had been around the block for a while, and he said that back in the day, they thought, wow, these things are dripping, they're forming, they're being renewed, which is true. And so at every end of every tour, they would the tour guy would knock off of a stalagmite and give it to someone as a souvenir, and they'd get a tip, right? And so that was, thought to be, it's a renewable resource. And it is renewable, but not on
not on our scale.
It turns out that places like Cave of the Winds down there, the sort of average rate at which those things form is it takes about 100 to 200 years, depending on where you are and so forth, to form a piece that's about half the size of a golf ball.
Isn't that
so
something?
So it's about 100-ish years per cubic inch. And you think about, you whack off one of these, it's going to take
500 years,
hundreds of years to form at best. In some places like Glenwood Caverns, which is the one that's up in the mountains west of here, takes 1,000 years.
Isn't that something?
So I don't know about you, but I'm not going to be around that fast. So, when one of the things that you hear again and again when you go into caves is, please don't take anything, but also don't touch the surfaces. I've been told that the oils in our hands or maybe sunscreen, which I wear a lot of here in Colorado, negatively interacts with that precipitation process, the process by which that mineralization occurs. And so we have some great specimens in our museum that were collected back in the day.
Right.
But they've already been contaminated, if you will, with oils and so forth, such that they couldn't really be repatriated to a cave.
Right.
So they are renewable resources, but on a very long time scale. Let's we got a kind of an action shot here. Yeah, let's look at this cross section. So I don't know if you guys can see this here, but the image on the left is actually a droplet coming off, kind of caught as it's about to fall on one of these stalactites. And the image on the right, it kind of looks like two arches, but this is a stalagmite that's been cut in half along its long axis, so sliced, and you can see the different brown and gold and white layers in it. And this thing grew basically from the bottom to the top, kind of like as if you were to take a paintbrush or maybe a frosting spatula and put a very thin veneer of frosting on the bottom and kind of a little dome, and then put another little layer of frosting on it. And okay, it's not really nature's frosting, but these are the examples of the layering in them. You had a great question about the time record in these, and so those layers each represent a moment of deposition, and scientists that study these have been able to go back and figure out, well, it was a wet spring, so there was more water infiltrating in the ground, therefore there was more dripping. So, and I'm making this up as an example, we got a thicker layer growing dripping from the top or building up on the bottom.
And there was a slight difference in composition. It was heavier in iron, or it was heavier in some ion that was causing the coloration that created these bands of different colors within.
Yeah, so iron is a good one. So a lot of times, if you've ever been to a creek in the woods, right, and you see the stream, and what the stream isn't always aqua blue, is it? Sometimes it's brown or it's kind of golden colored, and that's a rusty color, and that's iron or humic acid or fulvic acids, which are coming from the decomposition of leaves and pine needles and roots, and that works its way down into the ground, and it causes those colors that we see. And and so let's take a look back at that cross section. You can see, gosh, the color varies quite a lot. So one year there was a lot of iron and various acids. Other years there were hardly none. And so does that represent, for example, a year when it was maybe really dry, and or maybe another year when there was a lot more snow melt? Those are the kinds of things that one can figure out looking at these. So
interesting.
Plus, they're just cool. I mean, look at those. Wouldn't those make awesome bookends? Like, I want some bookends like those, right?
Yeah, exactly. They're fascinating.
Beautiful, beautiful. And you can polish these. The polish on these is like
And
glass.
it's unusual to see one of the speleothems, of the stalagmite in this particular case, sliced down the long axis. Usually they're cut perpendicular to the long axis, and you get the beautiful patterns such as you're seeing in this particular slide.
Yeah, so it's more like most of us cut a carrot in the short little chunks, right? And that's usually how they cut these. But if you cut a carrot long ways, you get a long kind of triangle, and that shows you how the carrot grew. Well, in this case, these are calcite carrots. I don't know. And but it's fun. I mean, it's a beautiful
they're fascinating and beautiful.
Yeah. Hey, let's take a look at this slide right here. One of the things we were talking about was the color. This is just an example. This is from Wisconsin, and I just got to give a shout out to all the Wisconsinites out there, including my wife, kids, grandma, grandpa, aunts and uncles, and Go Packers, of course. John Brower from Venice, and all my buddies and colleagues up in Mosinee and vicinity up in central Wisconsin, where I spent 10 summers learning the geology. So this is from Cave in the Mountains in Wisconsin, one of the best states. And look at all the different colors.
That's where I was born.
You're a Wisconsinite too? Holy smokes! Gosh!
And
let's go get some curds and some. Let's go get some cheese curds, some and a frozen custard.
Right next to Kettle Moraine State Park.
Oh, Kettle Moraine! Yeah, what a wonderful area. Yeah, we're going to be out in that neck of the woods over the 4th of July, so visiting Grandpa, and we might eat some curds and some other things, and some relishes. But that cave alone, look, it's got yellow calcite, it's got black calcite, it's got brown, it's got gold, it's got white. I mean, those are all recording different if you will, precipitates of different kinds of groundwater.
And it's interesting how it looks like that's almost a curtain rather than an individual stalagmite or stalactite. It looks like it might have been along a fracture system where it was dripping.
That's exactly it. In fact, you can get curtains and shrubberies and plates and things. You know, my favorite type of speleothem? Bacon.
Okay.
There are ones, and we'll show you a bacon in a minute, but bacon, it looks just like a breakfast
Isn't that
slab
something?
of delicious, striped kind of, you can see where the meat is and the fat, and you just want to reach, do this.
Have
you
a
want to
bite.
reach over and just
Have a bite.
So, and those tend to grow out of cracks because they're all oozing at once as a drip line rather than as an individual drop point. So, hey, let's take a look at this. What's our next cave up here? So this is Groaning Cave, and Groaning Cave is Colorado's longest or biggest cave system. It's 11 miles long. I don't want to get lost in that cave.
No.
By the way, just a shout out, the people that go into caves to explore them are, I think, part daredevil and part incredibly well-trained professionals. So if you guys are thinking about going into caves, please go with someone who's a member of a society who studies this and knows this. There are a lot of gases in caves as well as other dangerous features in them that you really got to be cautious in going into. It's just like going into an old mine.
It really is. And one of the nice things, like I mentioned earlier, is that so many organizations and corporations have preserved caves that they've actually put concrete walkways with handrails and different things to lights to help the general public go through them. I was on a trip down near Playa del Carmen, and there's some caves you can go into that are absolutely beautiful. They're little underground rivers that they've carved their way through the limestone deposits there. Beautiful cave formations in them, and you're actually floating through the cave and the underground river, and it's and walking as well. But you're in waist high to chest deep water, and just beautiful cave formations. And they're organized tours. You get in your wetsuit and go down there and go through. Fortunately, Richard, I think we have some in our archives from Minerals Live.
Yeah,
Richard did not want to put me through the pictures of Steve in a wetsuit. It looks a little bit like Orca.
All right. We'll do that next episode, okay?
There you go.
Yeah.
Exactly.
Anyway, so Groaning Cave is our biggest, and there are some caves that are, on the order of 750 feet deep, 300 feet deep, with caverns that are, 50, 60 feet in size. And think about 50, that's a 5-story building that you could put underground, basically. Right. I mean, that's gigantic, or larger in some cases. Yeah. So these things can be quite large. And those are ones that are just here in Colorado, which by no means has the biggest or best cave systems, but we've got some really nice ones here because we have carbonate rocks that have been lifted up by the mountains and they're getting dissolved away. So, and occasionally you do get cave systems also, we should mention, in evaporite deposits like gypsum deposits and anhydrite deposits too.
Sure.
Although those are a little bit more tenuous in terms of going in and out of them.
And you'll even get small cave deposits in some of the mineralized copper oxidized zones in copper mines.
Like down near Morenci and Ajo down in Arizona.
Ajo,
with some beautiful
Azurite and
Malachite. Yeah, we'll take a look at some of those in a minute. So. Let's go take a look at Cave of the Winds just for fun. I mean, Cave of the Winds is an amazing place. I mean, look at that cave. And you can see the railings. You can walk through there. And this is like walking into a grotto, if you will. And so the Cave of the Winds was basically formed in a unit of rock here deposited about 480 million years ago called the Manitou Limestone. And you've heard of Manitou Springs.
Yes.
Manitou Springs comes out of basically the same waters that are percolating through there. And they're actually naturally carbonated waters.
So this, as you drive by, is fairly high on the mountainside. So was that formed and then lifted up? Or was that at its current elevation and carved out by groundwater coming through?
We think it was carved actually when it was underwater.
Okay.
When it was saturated with groundwater on the order of 4 to 7 million years ago.
Okay.
And part of that cave and the entry to it is probably gone. It's been widened. But there are actually lots of caves in that area. The main one that visitors go through, the Cave of the Winds, was probably actually at that or close to that elevation when it was formed. Those rocks got lifted up there 65 million years ago.
Okay, so it was lifted up long before the cave formed.
But the springs were are part of that whole network. I mean, when you think about caves, it's not just a cave; it's a system, right? And they may involve creeks, springs, caves, vapors, cracks, fissures, pipes, karst. The whole thing. It's like talking about glacial terrains in Wisconsin. It includes kettle lakes, it includes moraines, it includes all the things that are part of that glacial system.
Okay.
So, but one of the ways that these things form, for example, down in that area, is basically water is seeping through decomposing material in the soils and rocks above it. It picks up a little bit of carbon dioxide, and that carbon dioxide makes carbonic acid with water, but it also carbonates the water a little bit, and so there's actually some springs, and you can go there, the general public, there's actually a tap down there and get bubbly spring water.
Isn't that something?
In that area.
Yeah.
It has a, bit of an aroma to it.
Yes,
but,
I'm sure.
It's a geological aroma, so it's pretty fun. One of the things about Cave of the Winds that's pretty fun is that, it was discovered back in the 1860s, not too long after Colorado's gold rush. And it opened in 1881, and it's the longest continuously operated attraction in Colorado. And
that's interesting.
I feel a little tug at my heart to say that because I'd like to say the Denver Museum is, but we've only been around 110, 115 years.
That's quite a history.
This place has been open continuously since 1881.
Isn't that something?
It's pretty cool.
That is cool.
The thing is that it was actually probably discovered about 1,000 years ago by the Apaches, and I'm going to read this name, and excuse me if I mispronounce it, but the Jicarilla Apaches are reputed to have found this, about 1000 AD. At least there are some oral reports of that.
Now, was there any indication in this particular cave that there's any drawings produced by the Indians?
I don't know about that. We should ask the folks down at Cave of the Winds. But there is a saying about the Great Spirit of the Wind, which is where Cave of the Winds gets its name. It's not a gringo name. It's from the Apaches. And a lot of these caves, both Cave of the Winds and, for example, Glenwood Caverns, are said to have whistled. The mountain is said to have whistled like, or maybe more like,
right.
As you had the right gusts of winds, and also as they cool or heat up, that's going to cause a pressure differential that could actually cause air to emit. And so they're said to have whistled, and who knows if that's how these were originally discovered, but I like to think about a whistling cave as I'm up there.
That is cool.
So, other sort of Western settlers, discovered these later on, but, I'm sure people heard these things whistled long before, and the animals certainly did. So. Let's go to the next image right here. This is just a picture of kind of a historical picture of these caves back in the day, and then a view of some of the ladders that you can go into.
Isn't that neat?
And why don't we talk about Glenwood while we're here? So Glenwood Caverns is the next image, Richard.
Okay.
And you can see on the top here, do you see the bacon?
Yeah.
Doesn't it look at those gigantic strips of bacon on the ceiling there, just delicious. There's also popcorn in these caves,
Yeah.
in case you need a snack, although it's very crunchy popcorn. But this cave was found probably by the Ute Indians. And the Utes are one of the native tribes of Colorado before Colorado was a territory or even a state. And they would come to the caverns. There were actually natural vapor caverns there, and also springs of water flowing out, certainly at least a couple hundred years ago. And they called these yampa, or sort of big medicine. And so it was spiritually a very relevant place. It wasn't until sort of the late 1800s, early 1900s that Westerners really, in fact, excavated some of the entryways to these caves to make the springs that we think of today, and allowed visitors into them on a regular basis to tour what was called Fairy Cave or Fairy Caverns. And so if you're up in that neck of the woods, check it out. In that case, that cave is, well, let's take a peek at some of the things. Yeah, that's a great one right there. Let's take a look at these images. This is just an example in the upper left of some of these things. The lower right is someone, of course, having a wonderful time in one of the vapor caves.
Like
it's like a spa, actually. It's like a natural spa. And there are man-made ones of these that exist elsewhere. This is the only natural one in North America. And of course there are crazy rides and so forth up there, and you could take a gondola up there, which is super fun, or a super sketchy bus ride. I feel like I'm going to fall off the cliff.
Yeah.
But this is actually in the Leadville Limestone.
Okay.
The Leadville Limestone's a unit that's really famous in Colorado. If you're from the Grand Canyon where I just was, the Leadville is also known as the Red Wall Limestone. It makes up the huge cliffs on the edges of the Grand Canyon. If you're from Montana or Wyoming, it's also known as the Madison Limestone. And you go up to the Bighorns or huge mountain ranges, you see these giant limestone cliffs, and it's the same reef complex that we have here in Colorado.
Interesting.
And it's a famous unit because a lot of the minerals that are mined in Colorado, both to collect and to use for industrial purposes like molybdenum, gold, silver, rhodochrosite, the list goes on. Many of them, and the Yule marble, occur in fractures or in cavities in the same Leadville limestone.
Interesting.
And so that's a unit of rock that just keeps coming back and back into our geological mineral story here. So
interesting.
And the cracks and caverns in there are what Glenwood Caverns is basically owes its existence to.
Interesting.
So that unit of rock just seems to be everywhere.
That's cool.
It's super fun.
It is.
So let's take a look at something even crazier here. This is a picture on the top of some crystals. And there are two pictures on the left. Let's talk about the one on the bottom left first. So this is a mineral that I'm actually not too familiar with. It's called anthodite. And it's basically acicular aragonite that occurs in fairly large sprays. And I don't know if there's a scale bar, but these are sort of centimeter to multi-centimeter size sprays. Just the kind of thing that if you sneeze, they would go poof. But beautiful, highly collectible minerals. And then on the right, on the bottom here, these are of course gypsum flowers. They look like they just came out of a baker's frosting.
Now these in a cave formation would also be called speleothems, even though they're not calcite forms.
Yeah.
Okay.
Travertine, which is formed by hot waters, and travertine's a common building stone, is kind of under the broader umbrella of speleothems. And there's sort of a debate about the nomenclature used. Is it a travertine? Is it a speleothem? Was the water hot? Was it warm? Was it cold? And I don't think we should wade into that debate. But most earth scientists will just sort of say speleothem.
Okay.
It's like saying carbonate or sulfate. It's kind of a safe word that implies cave. But what's a crack in a rock? It's a little cave, right? It doesn't have to be a giant room. So, apologies to speleologists out there, or travertinologists, but you can't always tell from the mineral, from looking at it. Was the water hot? How gaseous was it? Was it bubbling or not? We don't really know.
All right. Interesting.
But let's go back to this.
Yeah.
Like, this is just going to blow your guys' mind. So this thing on the top, those are big crystals of gypsum.
Yes, they are.
And there's a scale in here.
Yeah.
And those little yellow things on the left there, those are people.
Isn't that amazing? That is just amazing.
This is the cave of crystals. And so just let that sink in. These are real, naturally produced gypsum crystals. These are among the largest crystals of any kind that a person could actually touch on Earth. And they're a type of speleothem.
That's down in Mexico.
This is down in Mexico in Naka. Let's keep on this slide for a minute. And so these things are thought to form in kind of this crazy reaction where you have cool kind of oxygenated surface waters sort of oozing downward beneath an area that has hot,
Yes.
hydrothermally active groundwaters that are rich in calcium and other dissolved ions, and they kind of meet in the middle. And in this very hot cave, which incidentally is 118 degrees.
Wow.
You can't stay long.
It's 90% humidity. These guys are wearing yellow suits
Yes.
because they have basically an ice-filled backpack and a breathing apparatus, because you'll die in 30 minutes in that cave. And so this cave has been drained of water, as well as other caves in the area that are being mined for zinc and silver and lead and other things. But geologists and miners, you can go switch off that, have gone into that cave to basically check it out. And there was a great article, cover of Geology magazine, about about 15 years ago, maybe.
Yeah,
They
it's
found
been
this?
in a number of magazines.
I mean-
It's fascinating, the scale. And it was all over the internet when it was first released to the public. People were going, this has to be Photoshopped.
Yeah,
There's no
no,
way
no.
these tiny little people can be in these monster
I mean, these
crystals.
things are like, Steve and I together would look tiny next to
That's
one
right.
of those, and we're big guys, And these things are like, they're the size of, not quite of a sky, but of a tall building. They're huge.
They are.
Absolutely. And what's amazing is their shape, their crystal shape is perfect. And so that's the beauty of minerals, is whether you're looking at a micromount that's microscopic, or a thumbnail, or a specimen like this. This is a beautiful sort of half and half rhodochrosite speleothem, and you can see it nucleating off of maybe I don't know, I'm going to guess a piece of grass or a branch or a oozy blob.
Yeah.
Whether you're looking at something that's kind of mid-size or something enormous,
Yes.
all these crystals have more or less perfect shapes.
I always think of it as building blocks, the molecules coming together like a course of bricks that you're building. It's amazing that they take that form of that the molecules generate, and you get your six-sided crystals or rhombohedral crystals or whatever it might be. And it's
Wouldn't it be cool to have?
electrochemical attraction.
Wouldn't it be cool to have a mineralogy class in that cave?
Wow.
Field trip. I think it's kind of hard to get in there, but that's down near Nica, Mexico, and the Chihuahua area. And so areas that have a lot of evaporation, as well as hydrothermal, sort of basically hot fluids coming from a magma chamber. Those fluids usually come up through faults and cracks beneath. It's kind of like Goldilocks and the Three Bears. You got a magma chamber, you got some faults, fluids coming up, open cavity, voila, you get these amazing crystals. And so what's also exciting to me is that Cave of the Winds, that was discovered 100 years ago by Westerners. Glenwood Springs 150 years ago, but they discovered that cave like 15 or 20 years ago, and someone else is going to discover an even cooler one in the future in our lifetimes. So that ability to explore the earth and find things is amazing. Let's take a look at something from our museum here. So this is our own little Nica. This is a picture at the left from about 100 years ago of our crystal grotto, and this is supposed to reflect the stalagmites and stalactites and other speleothems from just above that cave we were looking at there.
Isn't
in
that
the
something?
same district. And that's a display that was at the museum. That's a picture from like 1909 or something, 1910. The picture at right that's in color, and that's a photograph was on the left, was from a newspaper. The picture at right is our current crystal grotto, which Jack Murphy and a team of volunteers reconstructed about 30 or 40 years ago, bit by bit by bit, to reconstruct the original cavern and augmented it with minerals from that very same district.
Yeah, it's beautiful.
And that's mostly, a lot of that is gypsum there, but it's something that as a visitor you can come and peer into the same kind of crystal cave, only it's not at 100 and plus degrees, because even the shallow caves can be quite warm if you're in an area of a lot of hydrothermal activity.
And yet others can be a nice afternoon respite from the hot summer air. You go underneath the cave and you're in 50 degrees or 60 degrees. It's a nice place to go spend the afternoon in the cool, naturally air-conditioned area.
Yeah, most caves are, and in this area, are 50, 60 degrees. I mean, they're cool. You go in there winter, it's cool. You go in there in the summer, it's cool. It's amazing. So, hey, let's take a look. What are some of these minerals here? These are some of the things we were talking about before. Steve.
Yeah, you've got Azurite and Malachite in the one to the right there, a nice cross-section of a stalagmite or stalactite that has been cut across perpendicular to the growth of it, and you get the nice banding of the green malachite and the blue azurite, which are both copper carbonate minerals. And in the lower left, you have a beautiful cross-section of an Argentina stalactite, and it's rhodochrosite predominantly, although there's likely some white calcite. Sometime you'll get a little bit of siderite, which is a brown carbonate, iron-rich carbonate that occurs with these as well. But here you're getting the beautiful concentric rings of the growth, the changes in chemistry as these grew over time.
That's a beautiful piece. It
really is.
It's like cutting a tree ring, except it's in a rock. And hey, rhodochrosite, our state mineral, it's basically calcite with a little bit of manganese shoved in lattice instead of the calcium. And our azurite and malachite are basically calcite with copper shoved in, and azurite just has a little bit more. It's got 3 parts of calcite, or of copper. To 2 for malachite, but just beautiful minerals.
Yeah, they are stunning. And you know what's fun at some of these, and I don't know if we'll have a slide of this, but some of the caves in Winshan in Yunnan province in China, they produce some incredibly well-formed calcite crystals that at times there'll be a flower growing and just such rosettes to individual crystals making a flower shape. They'll be on a stalk. I wish I had thought ahead to bring some in, but you'll have a stalk of probably was
like
hanging
a stalk
upside
like
down,
this,
right?
Actually.
And then on the termination of the stalk, there's these beautiful flowers of calcite, super well formed, highly lustrous, just in incredible formations that are great for our mineral collector friends. Will buy these. That we import a number of them from China, and you get very elaborate, very attractive formations. In fact, Richard just
hey, let's check one of these out. All right. See, the Collector's Edge does everything. Isn't this great? Wow.
Yeah.
Check this out.
Yeah. And so extremely well-formed calcite crystals. You can see the lovely terminations on them, and they're sitting on top of a speleothem, a stalactite or stalagmite. I'm not sure which way this grew, whether you were at a water level here somewhere where something changed.
Well, what's interesting is, so this is looks to me like a dripstone or a straw. And so if I had to guess, that was probably growing from the ceiling.
From the ceiling.
And then these euhedral crystals, though, they're not going to grow in an open cavity that doesn't have water in it. So just a guess.
It was formed upside down.
What if this thing dripped down to the bottom?
Yep.
And
got into the water.
And maybe even dripped a little bit farther, and then the water level rose, such that this was now saturated. Such this is now saturated, and so these things are growing out into the cavities and completely enveloped in.
Isn't that neat?
In ion. So, like that specimen, I'd love to see that deposit. Probably has a pretty cool story to tell.
Yeah. And just really, it's amazing that you see these very intricate formations, and collectors just love these things.
Yeah, I mean, this one even has a story. So this one isn't quite as pretty, but you can see it's kind of like a red vine. The upper parts are pink, and then the lower half are brown. And so here's a specimen. You can actually probably figure out how it laid in the cave. There was the water level, right? So it grew, and it was able to form almost perfectly pink rhodochrosite. And then at some point in time, maybe the water levels rose, maybe maybe it broke off. We don't really know, but it then was bathed in water that had a little bit more iron in it rather than manganese, and so it went from being, because this isn't dirt on here, this is actually brown calcite. It went from being
pink,
beautiful pink. Sorry, the lighting
manganese carbonate.
Yeah, and sorry the lighting, but it went from pink to brown, and so. What I love about speleothems and all these, calcareous minerals or carbonate minerals is they all have a story to tell, and we're just figuring it out right now. So
exactly.
We're hypothesizing.
Exactly.
It's good to have context of the cave to do that. But one of the things that happens here in Colorado is because we have so many caves. There's a huge avocational community of people that not only enjoy the thrill and adventure of exploring caves and documenting them, but actually doing the science in them. And they're not all necessarily geologists that work at a museum or a university. A lot of them are just citizen scientists, and I want to highlight one right here. Let's take a look at this next slide. And so this is an example of a fellow who I'll give you the name of in just a second here in Sulphur Cave up near Steamboat Springs, Colorado. So, Amy, this is right in your neck of the woods, and he's looking with a tweezers and a headlamp, and look at those burly forearms. This guy's probably hung off a lot of rocks, and he's looking very carefully to see not just what kind of minerals are there, but what kind of bugs and critters are living in these weird cave environments. And this is a great image up on the right up here of gypsum, kind of hanging down. It's got a bead of water on one of them. But if you look carefully at the upper left, you see those little lines up there? What do you think that is?
I have no idea.
Charlotte made one of these.
Well.
It's web. It's a spider web. So here's a spider web growing on a mineral, and the mineral might eventually envelop that. You can
so it'd
see
be an inclusion within the mineral.
So the minerals are important not just for science and for beauty, but they're also kind of preservatives, if you will, of the biological record of these caves. And there are lots of famous paleontological deposits in caves. But there's a lot of critters that are living in there even today that are never before been seen by man. And so let's take a look at a few of these. So let's take a look. So first of all, I want to give a shout out to David and Debbie Steinman and their son Nathan, 11, who's crawling out of this cave here, looking like they're having a good time. And I have not actually met them, but they are citizen scientists who work in partnership with our zoologists here at the Denver Museum. And they have made kind of an incredible inroads into understanding the biodiversity that lives in these weird mineralizing cave deposits of Colorado.
Looks like somebody lost a toupee there in the bottom.
Yeah, well, you know, if you want to wear that toupee, Steve, here, let me put it on right here. That toupee would do this. Because there are a bunch of really crazy, blood red, weirdly oxygenated worms that live in some of these sulfur-rich caves.
Yeah, I think I'll pass.
Yeah, we want to pass on that. Don't eat. I don't know if people eat them. But this is a daddy longlegs in the middle. I mean, all of these are new species that are...
Isn't that something?
That were discovered by this family and worked in partnership with scientists at our museum and elsewhere to describe it. There's a brand new daddy longlegs. Imagine that thing crawling across you in a cave in the middle of the night. Maybe it's hanging out with one of those webs. We've got millipedes up at the upper right. These are shown in a microscope. So these little millipedes are probably crawling over you if you sleep in one of these caves at night. And
they're millipedes.
But just like a reef, a reef is its own ecosystem. I think of a cave as kind of an underground, weirdly mineralized ecosystem that, believe it or not, we're just beginning to understand. And
that's cool.
Over the last few years, there have been hundreds of brand new species of organisms described from caves right here in Colorado, and many of those are in the collections here at the Denver Museum. And so if you guys ever do any exploring of caves out there, don't just keep your eye out for really interesting and weird minerals, but keep an eye out about the critters that might be out there too, because it seems like there's a lot of discoveries to be made.
Yeah, it is. That's exciting.
Yeah, and that's about all I had to say about speleothems, other than they're fun and they're all around us. And don't leave any trash in the caves, or we'll have to go in there with a plastic bag and pick it up. Treat your caves as if they aren't renewable resources. But they're records for science, they're records for minerals, they're records for life. And
I think most of the public caves, it's amazing how well the message has been sent by the people operating these caves from the 1800s, where they would break one off and give it to you as a sample, one of the speleothems. Now they all instruct before you go down how careful you need to be and respectful of that environment when you're there. So I think they've done a good job of educating the public on what a treasure these underground systems are, and the speleothems are to be respected in those environments. So
and it's amazing that basically you're walking into a geode. Right? It's like a life-size geode.
And they're really cool.
If you have an opportunity to check one out, we encourage you to do so. There's some great ones here in Colorado, and if not, come down to the museum. We've got a crystal grotto that you can go up to and then go see some other cool minerals too. So
sure.
Yeah.
Well, Doctor,
Steve.
it's been a pleasure having you with us once again on Minerals Live. You're always so educational. I know we get hundreds and hundreds of viewers that respond back and say, when can we have Dr. Hagadorn on again?
Well, hopefully sometime in the future. You know, one of the things I should mention is that I'm on Facebook, Twitter, and Instagram, and LinkedIn, and I post probably 5 days a week something to do with geology or earth sciences, whether it be a mineral or a fossil or a weird worm that lives in a crazy mineral environment or something like that. And so if you want to follow me on social media, you know, look me up. I'm out there, and stay tuned for the next Minerals Live. So,
There you go.
Thanks a lot for tuning in, everyone.
Thank you so much.
Thanks, Amy. Thanks, Richard.
Thank you.
See
All
you.
right. I just want to give a quick shout that I'm heading west next week.
Yeah,
So
Richard
anybody on
is
the
headed
West
out on a trip to the West Coast. Any of our customers who would like Richard to stop by with a van full of rocks and give you a tour through our latest acquisitions. He will have some from a brand new collection that we've acquired, and some beautiful tourmalines and other worldwide minerals, and some of our new acquisitions from China. So if you're interested in seeing Richard on the road, send him an email, richard@collectorsedge.com. We'd love to cause a little detour in his route across California, Nevada, Arizona. He'll stop by and show you some cool rocks.
Happy to.
Yeah.
All right. Thanks, everybody.
Thanks, everybody.
Take
See you
care.
again next time on Minerals Live.
Yep.